Hi, good morning. I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this video, I would like to discuss the problems on Lagrange's linear equation in partial differential equations. So, we have seen already the Lagrange's linear equation. So, the form will be, just I will explain, the Lagrange's equation, the standard form is P, capital P, or small q into capital Q is equal to R, where capital P, capital Q and capital R are functions of x comma y comma z, and this equation is known as the Lagrange's linear equation. We call it as Lagrange's linear equation, or we call it as small capital P, small p, Q is equal to R. So to find the solution of this Lagrange's equation, we write first the subsidiary equations, that is dx by p is equal to dy by q is equal to dz by r, where p, q, r we know that it is these three are functions of x, y and z. Now this can be solved by using method of grouping and method of multipliers. So we know that how to do that already we have seen in the previous video. So that will explain in the given problems. And in this present video, I would like to solve these following problems. So px plus qy is equal to z, solve the differential equation. Find the general solution of p plus q is equal to 1. Solve p tan x plus q tan y is equal to z. And this is y square zp plus x square zq is equal to y square into x. So these problems I am going to solve in this video. So all are, you can observe that the Lagrange's linear equation, because all are in the form pp plus qq is equal to r. So I will solve it one by one. So first problem, solve the differential equation px plus qy is equal to z. So what we know that is a small p means it is dou z by dou x, and small q is equal to dou z by dou y. This is the linear equation. And I would like to solve, and this is in the form, you can observe that the above equation or the given equation is in the form small capital P small p plus capital Q small q is equal to R. So here, what is capital P? Capital P is equal to x, and capital Q is equal to y, and capital R is equal to z. So clearly this is the linear equation, and it is in the form of Lagrange's linear equation. So to solve this equation, first you have to write the subsidiary equation. Before that, I classified the value p is x and q is y and r is z. Now the subsidiary equations are dx by p is equal to dy by q is equal to dz by r. That is dx by p means what is x, all capital values, capital Q that means y, and dz by r means z. So these are the subsidiary, this equation is known as the subsidiary equation. So we know that the solution of this equation will be in the form phi of f comma or phi of f comma g is equal to 0, or u comma v is equal to 0. The general solution of this equation is in the form phi of u comma v is equal to 0, where u and v are solution set of this subsidiary equation solutions. Now on taking the first 1 and 2, on taking the first two equations, dx by x is equal to dy by y, on taking the first two equalities, then on integrating, what you will get, integral dx by x is equal to integral dy by y plus c, or we can say that it is log c, because these two are log values. Log x is equal to log y plus log c. Or what I can write it as log x minus log y is equal to some log c. Or what I can write log x by y is equal to log c, or x by y is equal to c is the first solution. This is u of x comma y, u of x y z. This is the first value of the solution and call this is equation number 2. Similarly, unequating the second and third equations. Unequating the second and third of equation 1. So dy by y is equal to dz by z. On taking integration both sides, log y is equal to log z plus log k. This is c constant. Here I am assuming it as k. Or log y minus log z is equal to log k. Or log y by z is equal to log k. Or y by z is equal to k. This is equation number 3. Now the general solution of this equation is in the form the phi of u comma v is equal to 0. Now the general solution, the general solution is phi of u comma v is equal to 0. That is phi of the first solution x by y. Am I right? And the second solution y of y comma z is equal to 0, which is the required solution of the given equation number 1, where phi is an arbitrary function. Phi is an arbitrary function. Phi of u comma v is equal to 0. So clearly this is in the Lagrange's linear equation form. Pp plus qq is equal to r, where p is equal to x, q, y, and r is equal to z. And on writing subsidiary equations and on solving, you'll get the required solution. Now, I'll go for another problem. Find the general solution of p plus q is equal to 1. P plus q is equal to 1. So clearly this is also in the form, the above equation, the given equation. First write the given equation. The given equation is small p plus small q is equal to 1. And it is a Lagrange's linear equation where capital P is equal to 1, capital Q is equal to 1, R is also 1. PP plus QQ is equal to 1. Now, the subsidiary equations are dx by p is equal to dy by q is equal to dz by r. Just we are following the working principle. So what is p here? Dx by 1 is equal to dy by 1 is equal to dz by 1. So on taking first two, what we will get? Dx is equal to dy. To find the solution, we take integration both sides. Integral dx is equal to integral dy plus c. Integral dx means x is equal to y plus c, or x minus y is equal to c, and this is equation number 1. X minus y is equal to c. Similarly, on taking second and third, dy by 1 is equal to, or dy is equal to dz. On taking last two equations, what are the last two equations? Dy by 1 is equal to dz by 1. On taking integration both sides, integral dy is equal to integral dz, or y is equal to z plus k, where k is the integrating constant. Then y minus z is equal to k. This is equation number 3. These are the equation number 1, because these are the subsidiary equations. And 2 and 3 are the solutions. U of xy z is equal to c and v of xy z is equal to c. Then the general solution, hence, the general solution will be phi of u comma v is equal to 0, where u is the first value, u is equal to c is the first constant, v is equal to c is the second function is equal to constant, and second value is y minus z is equal to 0, and which is the required solution of the given differential equation. As per the working rule, the solution will be the subsidiary equations y of u comma v is equal to 0, where u is a function of xyz in the form u of xyz is equal to some constant, and v is a function of xyz which is equal to some constant, and phi of c comma k is equal to 0 is the solution. C means x minus y and k means y minus z is the solution of the given partial differential equation. Right? This is very simple. Just you have to observe the working principle. You have to write p value, q value, r value and solve the equations. Thereafter you get the two solutions, and writing the two solution by writing in the phi of uv0 you will get the final solution. So similarly, I would like to solve another problem. Solve the differential equation p tan x plus q tan y is equal to z. P tan x plus q tan y is equal to z. First write the given partial differential equation is p tan x plus q tan y is equal to z. This is in the form small p plus capital P, small q plus capital Q is equal to R. Then what is here? What is P is equal to tan x and Q, that is tan y, and R is equal to Z. R is equal to Z. Now the subsidiary equations are dx by p is equal to dy by q is equal to dz by r. That is dx by p means what? Tan x is equal to dy by tan y is equal to dz by z. So I think right side also tan z. If there is a small doubt, this is tan z. So the right side also tan z, there is a r is equal to tan z. So dz by tan z. Now on considering first two equations, first two, what you will get? Cot x dx is equal to cot y dy. I'm considering the first two. Cot x dx is equal to cot y dy. On taking integration, integral cot x dx is equal to integral cot y dy. So what is integral cot x dx? That is log sin x is equal to log sin y plus log c. Log sin x plus log sin y is equal to plus log c. Or what I can write, log sin x minus log sin y is equal to log c. Or log sin x by sin y is equal to log c. Or what is the equation? That is, first one is sin x by sin y is equal to some constant. This is equation number 1, first solution. I'm considering the first two. You'll get the solution sin x by sin y is equal to c. Similarly, on taking last two, what are last two? dy by tan y is equal to dz by tan z. That is what we can write. Cot y dy is equal to cot z dz. So on taking integrating both sides, integral cot y dy is equal to integral cot z dz. Or integral cot y means it is log sin y is equal to log sin z plus some constant log k, where log k is the integrating constant. Or what I can write here, log sin y minus log sin z is equal to log k, or log sin y log m minus log n. I can write it as log m by n. Sin y minus by sin z is equal to log k. Or what is the solution? Sin y by sin z is equal to some constant k, and this is the second function. V of xyz is equal to some constant. Hence, the general solution is phi of u comma v is equal to 0. So what is the first solution? Phi of sin x by sin y. Second one, sin y by sin z is equal to 0 is the required solution of the given differential equation. So I hope this is clear. The first solution sin x by sin y is equal to c, and second solution sin y by sin z is equal to k. On writing the two solution into one solution, you'll get phi of sin x by sin y is equal to sin y by sin z, which is the required solution of the given partial differential equation. Similarly, we do the another problem. This is also comes from Lagrange's linear equation. Solve the differential equation y square zp is equal plus x square zq is equal to y square x. So what is the given equation? First write given equation. Y square z small p plus x square zq is equal to y square x. So this is in the form. So in what form it is? Capital P plus small p plus capital Q plus small q is equal to R. So what is this is? Lagrange's linear equation. This is in the form Lagrange's linear equation. D P small p plus Q small q is equal to R, where P, Q, R are functions of x comma y comma z. Here what is P? Here what is capital P? Y square z. The coefficient of P is y square z. And what is capital Q? X square z, capital Q, and R is equal to y square x. R is equal to y square x. Now, the subsidiary equations are dx by p is equal to dy by q is equal to dz by r. The equations dx by p plus dy by q is equal to dz by r. That is dx by p means y square z, and dy by q means x square z, and r means that is y square x. Now we can consider the equations first two one time, and you can consider the first and last second time. Now on considering first two, now on taking first two equations, What are the first two equations? Dx by y square z is equal to dy by x square z. Dy by x square z. So both sides z cancel. That is dx into x square is equal to y square into dy. So on integrating both sides, integral x square dx is equal to integral y square dy plus c, or x cube by 3 is equal to y cube by 3 plus c. Or how you can write x cube minus y cube is equal to 3c, or x cube minus y cube is equal to some constant c1. So this is the first solution. The phi of xyz is equal to c1. Similarly, on considering the first and last, because y square will be the common term that will be cancelled out, then you will get the terms in x and z. So I will consider the last two, dx by y square z. On taking last two equations, dx by y square z is equal to dz by y square into x. dz by y square into x. Or I can write it as a dx by z, y square, both sides cancel. That is a dz by x. Or on cross multiplying x dx is equal to z dz because of the variable separable. You can write x terms on dx side and z terms on dz side. And on integrating both sides, integral x dx is equal to integral z dz plus k. Here I have taken the constant c. Here the taking integrating constant k. Then it is x square by 2 is equal to z square by 2 plus k. Or what I can write, x square by 2 minus z square by 2 is equal to k, or x square minus z square is equal to 2k, or x square minus z square is equal to some k1 is the constant, and this is the second solution. So now what is the general solution? Hence, the general solution is given by phi of u comma v is equal to 0, where u means u of xyz is equal to c. That is the first solution. U of xyz is equal to c1 is the first solution, and second solution v of xyz is equal to some k1. So on writing these two solutions as one place, you'll write phi of x cube minus y cube comma x square minus z square is equal to 0, where phi is arbitrary function. So this is the required solution of the given partial differential equation, and which is in the form the PP plus QQ is equal to R. So in this way, we can solve the Lagrange's linear equations. You can take the solutions of dx by P is equal to dy by Q is equal to dz by R by taking method of grouping or method of Lagrange's multipliers. Method of grouping or method of multipliers. You can take any one. If possible, you can take it as a multiplier. That you can write each ratio. Each ratio is equal to dx plus dy plus dz by zeros formation. Then you can write the solution of that one. That is another solution. The commutation of the two solutions will be the required solution of the partial differential equation. So in our syllabus, we have only the Lagrange's linear equation by method of grouping and by method of multipliers. So both can be used by depending on the given problem. So these are the four problems which are important in finding the solution of a linear differential equation in partial mode. So these are the problems we have seen. Px plus qy is equal to z, and one is p plus q is equal to 1. It's very easy problem. Just you have to write the subsidiary equations and you have to find the solution sets. On writing the two solutions, you'll get the final solution. And here it is also in the form P tan x plus Q tan y is equal to tan Z, not Z, it is tan Z. So then on writing small capital P, capital Q, capital R, and taking the first two one time and last two one time, we'll get the two solutions, and the constitution of two solutions will be the final solution. So similarly, we have taken like this. This is also capital P small p plus capital Q small q is equal to R. So all are this model only. So here the target is to find the solution of this equation by doing one of the methods. So with these few models problems, I conclude my lecture. This book is taken from Dr. T.K.V. Iyengar, Dr. Krishna Gandhi, S. Ranganathan, MBS Prasad. A textbook of engineering mathematics, volume 2, page numbers 175 to 180. And the books published by S. Chan and Company Limited. So in the year 2001. So you can refer the book to get more problems, and you will have the more exercise problems also in the books. So you can do the problems by practice session. So with these few, thank you.
Like, share and subscribe. Hit the bell icon for more updates.